painting of this. Who are you? How did you get in here?
So it took 2 years, a new Windows installation, YouTube holding my money captive, one hacked and recovered Twitter account, a jerk saying that you can only learn engineering at school, and a pandemic, but I finally made a new video. Alright, so welcome to a new series that I want to make called How Not to Engineer. I designed a 3D printer. In early 2019, I thought that it might be a really cool challenge to try to design my own 3D printer, so I started working on that. Late 2019, my DaVinci printer started to die, so all I was left with was my home-built 3D printer that I named Piece of Crap. It's actually the open source Rostock printer from Thingiverse. Now that you're all caught up on that, the 3D printer that I built is literally made from a 3D printer named Piece of Crap and Garbage. So, we want to make a 3D printer. What's first? Well, first we need to understand 3D space. How is a print bed supposed to know where to exist? The best way to visualize this is with math. Let's draw a grid. So, we'll make the middle of the grid 0, and then we will go up by 5. The end of the grid is technically 25. Then the bottom of the grid is technically negative 25. For all intensive purposes, a set of these numbers is called an axis. So we have two axes here, X and Y. We can technically keep track of where anything is inside of this grid now. And the good news is if we want anything to return to exactly where it was, we know where to put it. But wait, this is only a 2D plane. How do we get a 3D space? Well, we add another axis. We're going to call this axis Z, and now we can put things in 3D space. Alright, cool. So now I know I need 3 planes of movement, the X, Y, and Z, for this to be able to 3D print. I decided on a print bed of 2 foot by 1 foot, or 609.6 millimeters by 304.8 millimeters. I got that measurement from a piece of metal that I found at Lowe's. So cool, now I can start designing my 3D print. But wait a second, I'm still working against the constraints of my own 3D printer. My 3D printer can't 3D print something that big. My Rostock printer can only print at 200 by 200 millimeters. And unless you know something that I don't, I cannot 3D print something larger than the print bed itself. So it doesn't take a genius to know that all you have to do is 3D print things in sections and then connect them together after it's done. Alright, so I can finally move into designing this, right? Well, we still have a problem due to material science. I will be printing this printer in ABS plastic, which is not strong at all. If I were to assemble this the way that it is, it would break under its own weight. So I'm going to have to build in metal supports. Fortunately, I did find some at Lowe's. Alright, so metal supports should keep everything lined up. So I'm going to design all of this to be modular, so everything can be taken apart and put back together in smaller pieces with built-in metal supports to keep everything together. So to power this device, I'm going to be using a stepper motor. I have no clue what type of stepper motor this is. I think you put a rod through it, but I want a whole bunch of them on eBay, so why not? I'm going to take a pair of dial calipers and measure the stepper motor, and then translate that into a 3D model on my computer. So most printers use a belt. I don't have the patience for belts, so I'm going to try to figure out a way around belts. I want a tooth and gear system that locks in place. Oh wait, somebody's already done that. Well, that just demonstrates that the theory works. I also need to make sure that there are 2 linear rails in which bearings can slide across. The linear rails will have to be at least 1,228 millimeters long to get the full range of the print bed. On top of all that, I'm also going to have an internal structure so I can put a drill rod through it so I can have that metal bracing, and a tunnel through it so I can feed wires from the end stop to the main board. The end stop's just a little button that tells the 3D printer when it's hit 0 or the end of its track. So in theory, when I'm done, that's what it should look like. So you can see here's the stepper motor, so there's these little slots, and that's what I'm going to use to connect to the pieces. So, here's my pen. It slots into those two little slots there, and it grips the motor. It's connected on both sides to retain it inside. Here I'm just putting together the housing that will hold the stepper motor in place. I did change this design later on. So you can see the stepper motor is on sliders that push it up and down. I got rid of that later. So this slots onto the center piece. This has to withstand a lot of force to move that print bed back and forth. That is an end piece. It is all connected to that rail piece. And of course I'm only doing one side. Here I'm connecting it to the metal bracing that I found. The railing slotted to allow room for that metal bracing. And this is the end of the railing. So you can see it wobbled around. So I'm taking the metal drill rod and then I can just screw it through the entire thing. And then I just screw that end piece on. Here is the end stop here. That is the holder for it. You can see the wire nicely goes through the slots that I 3D printed inside. The bed, just like a lot of things, would be a nightmare to completely take apart and reassemble, so I'm just going to show you how it's put together on blueprints. Alright, so the next thing that we're going to worry about is the Z-axis. How many 3D printers handle this is just a drill rod with a nut. If you lock the nut in one position and you spin the entire rod, the nut will want to unscrew or screw in, which raises and lowers. So just like I learned from the print bed, I want a linear rail system to hold that nut in place. Alright, so now we're down to our last axis, which is the x-axis. This is going to be the print head or the hot end. So this is about the time that I design a belt system.
Wrong!
I don't have patience for belts. I don't like belts. I hate belts.
I hate
Belts. You have to do so much maintenance with belts, like tighten them and make sure they don't wear out and replace them. No belts. So to achieve this, I'm going to put the stepper motor on the hot end itself and move the entire assembly across the linear rail that has the teeth gearing in it. I'm going to have 2 metal supports in it, 1 drill rod and 1 smooth rod. I do not have video of this getting assembled because once I assembled it, I was not going to take it back apart for this video. And that's pretty much it. I didn't run into too many problems with the firmware. I was using the Moron firmware. The only thing I had to do was this. After that, I didn't run into any problems at all. Well, I think I'm going to leave it here. If you like the video, go ahead and hit the like button. Subscribe for more projects. Make sure you put screw holes in accessible places.
Don't ask me how I learned that.
And I hope this video inspires you to make something awesome. Or at least better than me. Actually, anything's better than me. If you make a sandwich, it's probably better than this.